Hi and welcome to the On Maths prediction for the Edexcel Higher Paper 3 GCSE Maths 2018. Enjoy! Hiya, okay, so I hope paper 1 and 2 went alright. We've now removed the paper 1 and 2 topics to get you a paper 3 prediction. Like I've said in the previous videos, please use this in amongst all your other revision. There's plenty of topic busters on the site which cover all the GCSE topics, not just the ones in this prediction. The downside of a prediction is it can only be the amount of marks in the paper. There are plenty of topics that could come up that still haven't, and also the exam boards are notorious in repeating some of the previous topics. So use this as a starting point, or use this as a bit of a revision break, a revision check, but please also do the standard revision as you would normally, and see this just as a revision tool. Like always, you can do this online at onmaths.com. Also, if the servers get busy, which they normally do probably the day before the exam, then please use our backup site, which will be in the description. I hope you enjoy this video, and if you like it, please click like. If you really like it and want to see more from us, click subscribe. Thank you very much. When you're rounding numbers to significant figures, first of all write out the number. And with significant figures, you want to draw a line after the second number. So the 6 is the first number, the 3 is the second number. Now, unlike decimal places, you're not looking at counting from the decimal point. You're counting from the start of the number, and we'll have a look at an exception to that on question B. Then we look at this number. Now, this number and the 2 are doomed. They're gone. But they're not quite done yet. That blue one has to make a decision. If that number is a 5 or more, that 3 will go up by 1. If it's less than 5, that 3 will stay the same. Now, because it's less than 5, that 3 will stay the same. But have a think about it. If 6,312 people visited or were at a football match, and someone said, "Oh, can you tell me roughly how many that was?" If you said 63, that doesn't make any kind of sense. So the mistake that I've made, and the mistake most people make with this question, is they forget that the 1 and the 2 don't disappear. They turn to 0. So the answer is 6,300. Now on question B, this is an exception that we've got to remember with significant figures. You don't start counting until you hit a number that's not a 0. So the first number is 5 and the second one is 2. So the line will go here. Then let's have a look at our decider number, where it's 1 again, so it's less than 5. So we're going to have 0.052. Now, I could put 0, 0 in here, but this time the numbers aren't actually affecting anything. Was before, the 2 zeros there were holding that 6 to 6,000 and the 3 to 300, so they were really important. The zeros here aren't actually changing the number at all, so we don't need to have them. So the answer is 0.052. So we're given quite a basic diagram. We're given a pair of parallel lines and we're given 2 angles from them. And angles on the parallel lines, there are 4 things you should be thinking about. So the first one is corresponding. Those are F angles. The next one is alternate, which are Z angles. The next one has loads of names. It's co-interior, interior, allied, whichever your teacher says. And the last one is vertically opposite. Now, vertically opposite occur in other places as well, not just parallel lines, but that's normally the one that you will be using. So let's have a look. Well, what letter does that make? So if I draw out from the parallel lines, I always say it's the armpits of the letter. So if it's a Z, it's the armpits of the Z. And if it's an F, it's the armpits of the F. Well, this is like an upside down backwards F. So we know that upside down backwards F, any F angles are going to be the same. So I know that's 62 degrees. Now we've got to give a reason. So the reason is corresponding. Now I always got corresponding and alternate mixed up, so I don't know whether this will help you, but I always think corresponding and alternate. Please don't spell it that way, but I just literally bung the letter into the word and I've never got them muddled up since, so that might help you. The other one, the C angle, are not equal, so these ones here are not equal. They add up to 180 degrees. So just be careful with that. The rule of thumb is if you're guessing and they look the same, even if it says it's not drawn to scale, if they look the same, then if you have no other memory of what they're likely to be, if you forget about angles on parallel lines, just write down the same angle. If the one's acute and one's obtuse, just take it away from 180 degrees and maybe you'll get some marks. But hopefully you'll remember the corresponding alternate, co-interior or interior or allied, and vertically opposite. Okay, so we've got a scattergraph question, and the first question asks us just to plot the information from the table into the scattergraph. So we've got ice cream sales at the top and temperature at the bottom, which is not kind of the same way around as on the graph, so we've just got to be careful. So the ice cream sales are 46, which is here on the scale, and the temperature is 31, which is here on the scale. Just check that you're looking at the scale correctly. So we're looking about, let's have a look, about here. Okay, next one, ice cream sales 40, which is here on the scale, and temperature 34, which is here. So we've just got to be careful, and it's about there. So those are the two plots that we want to take. Next question says, on another day had an average temperature of 45 degrees. Use the scattergraph to estimate the sales of the day. Now, you need to get used to just drawing a line of best fit to any scattergraph that you come across. You will have to do it, okay? So just do it. Just, even if it doesn't ask you to, just draw a line of best fit. Now, a line of best fit is just a line that follows all the data like that. You should have roughly the same amount of data top and bottom, but it doesn't matter if it's not perfect, okay? So let's have a look. So we've got average temperature of 45 degrees. So we're going to draw a line up from 45 degrees, which is about there. And we're going to draw, oh, the line didn't come up. So let's draw that line there. It's refusing to come up for some reason. Let's try another one. There we go. Let's try another line. Okay, let's do it the old-fashioned way. Okay, and then we draw a line across from where it's the line of best fit. Now, to me, that looks like about 55. But if you had the same question and you came up with a different answer of 54 or 58, it still can be correct because you might have drawn a slightly different line of best fit. Okay, so don't worry if you sit down next to someone, do the same question and get a slightly different answer. Just draw the lines, straight lines, unlike mine, onto your diagram to show the examiner that you worked it out. So we've got 55 sales we're predicting. Now, what do we notice about this? Well, look at where all the data is. All the data is here, and yet we're estimating outside the range of the data. Okay, it's called extrapolation, where you do that. So the problem with that, if you imagine we do a graph of height against age, so we have age at the bottom and height up the side, then when you're very young, you grow quite quickly. And if someone extrapolated your data and said, oh, okay, well, that growth is going to continue, when you're 80 years old, you're going to be 20 foot high. Well, that doesn't make much sense. It's because we're quite confident with down here because we've got data for that, but we're not very confident with this bit here. we don't know whether the trend continues. Now with ice cream sales, if it's ridiculously hot, no one's going to leave their house. They're all going to be sitting inside with their air conditioning or sitting in their car with their air conditioning. So we know it probably won't continue. So if you just say that the estimate is outside the range of the data, and if you want to really impress the examiner, then you can use the word extrapolated. It's been extrapolated. Okay, factorise means put it into brackets. So looking at the first one, there's a t I can divide out of both of them, so I put t on the outside of the bracket, but there's no number because 7 and 5 don't have anything that goes into both of them. So I think, what do I times t by to get to 7t squared? Well, it's going to be 7t. And what do I times t by to get to 5t? Well, it's just going to be 5. You can check your answer by expanding the bracket, check it makes 7t squared plus 5t, which it does. Next one, w is only in the first term, so I can't divide out the w, but there's a number I can divide out of both of those. Now, I could pick 2, but actually 4 is a better number because it says factorise fully, which means I need to take out or divide out the 4 rather than just the 2. So 4 on the outside. What do I times 4 by to get to 12w? Well, 3w. And what do I times 4 by to get to minus 8? It's going to be minus 2. And again, I can expand that to check it. Right, the last one, there's a number and a letter. So I'm thinking the number of 16 and 24 would be 8, and the letter would be A. Okay, so there's two things that we're dividing out this time. So I'm going to have 8a on the outside. So I figure out, what do I times 8 by to get to 24? Well, that's 3. And what do I times a by to get to a squared? Well, that's going to be a. What do I times 8 by to get to 16? 2. And what do I times 2 by to get to 16a? So it's just going to leave it because the a is on the outside of the bracket. So a to a times 2 is 16a, so I don't need an a there. Okay, so we're asked to write 88 as a product of its prime factors. So the first thing to do is write 88, and then we have two shoots coming from it. Now I need to find out which two numbers times together to make 88. Now a little tip, if you've got an even number, always pick 2. So 2 times 44. Now whenever we get to a prime number, we always circle it, because that's finished. So 44, we can get another 2 out of that, we'll divide another 2 out of that, so 2 and 22, 2 and 11. Now 11 is also a prime number, and when you're left with just prime numbers, then you write your answer out like this. Now if you're also asked to write it in index form, that means instead of 2 times 2 times 2, you're going to write 2 to the power of 3 times 11. Now don't work that out because that will give you 88, so 2 cubed times 11 is 88. So when you have a right angled triangle and you're given 2 of the lengths, and you're asked to find a third length, which I'm going to call x, then it's going to be Pythagoras. Be careful, because if there's an angle involved, either you're asked to find an angle or you're just given an angle on the side, then you'll be using trigonometry. So when we use Pythagoras, there are 2 methods that I know of to work it out. There's the algebraic method, which is a squared plus b squared equals c squared, and that's absolutely fine to use. I'm not going to use that method because if you're happy using that method, go on, use it, not a problem. The only thing to remember about that method is that c must be the hypotenuse. Okay, now I'm going to do a method that doesn't involve algebra at all for people who are not very happy with the a squared plus b squared equals c squared method. So my method comes with 3 steps. Step 1 is just square every number that you have and put the biggest one first. Okay, so I'm going to do 7.1 squared and I'm going to do 4.6 squared. So on my calculator, 7.1 squared, and that equals 50.41, and 4.6 squared equals 21.16. So step 1's done, I've squared them all. Step 2 is the only choice you have to make. You either have to add or subtract. Okay, now this is where we talk about the hypotenuse. The hypotenuse is the length that's opposite the right angle. So go to the right angle, go across from it, and that is the hypotenuse. So 7.1 is the hypotenuse. Now what's special about the hypotenuse and why it has a special name is it must be the longest side. So in step 2, have a think, well, if we add them, we'll get a bigger number. Well, the hypotenuse must be the biggest side. So when you're finding another side, not the hypotenuse, you will subtract. But if I was finding the hypotenuse, so I wanted a bigger number than the other two, then I would add. So I'm going to do 50.41 minus 21.16, and that's why in step 1 we did the biggest one first, because otherwise you'll get a negative number. So 50.41 take away 21.16, and that equals 29.25. Okay, and step 3 is a nice easy step, it's just root it. So with this one, I'm just going to press square root answer, and then I have, so I'm going to write that down, square root 29.25, and so that equals 5.4083, blah blah blah. It says it wants its 2 decimal places, so I'm going to write 5.41 because that 8 moves that 0 up by 1. Now, last step is just check it makes sense. Well, this being 5.41 means that the 7.1 is still the longest side, so we know we've probably got it right. Okay, for Venn diagrams it's really important to understand the notation. This symbol here means union, it just means or. It means it can be in A, or it can be in B, or it can be in both. So it's any number inside either circle. So I could have 9, 5, 3, 7, 18, or 2. Let's go for 9, but the other 5 would be correct. This symbol here, I always view it as an and. I always put a little line there to say A for and. And it means it needs to be in A and B. It can't just be in A, it can't just be in B, it needs to be in both. And there's 2 numbers that fit that bill, 3 and 7. So I could write 3 or I could write 7. Now this little symbol here, okay, and it's an A with a dash. That dash there means not. So we're looking for numbers that aren't in A and are in B. Well, let's have a look at where not A is. Well, it's anywhere around here. Anywhere around here is not in A. And let's have a look at where B is. So B is anywhere here. So the numbers that overlap both of those are the 18 and the 2. So it's 18 and 2. So there are 2 numbers that fit that bill, so that will go at the top of our fraction, and there's 1, 2, 3, 4, 5, 6, 7, 8 in total. Now I can simplify that a little bit to make it a quarter, and so my answer to that will be 1/4, or a quarter. Okay, to convert from standard form, you just write the number down, and this here, the power, will tell you where to go. So if the power is positive, then you go to the right. If it's negative, then you jump to the left. Now since it's negative, we're going to jump to the left, and it's -6, so we're going to jump 6 spaces. So 1, 2, 3, 4, 5, and 6. So the decimal point will now be here, and you fill in all of the jumps with zeros. So one of the jumps is used by the 8, but all the other ones we fill in with zeros. And whenever you've got just a decimal point, you need to have something before it, so we put a 0 before it. So the answer will be 0.00000084. That would be the answer. So let's just count. There's 5 zeros and 5 zeros. Okay, to convert to standard form, you write out the number and you try and put a decimal place in to make the number between 1 and 10, but not including 10. So if I put it in here, that would be 72, so that would not be right. So I need to put it in here. Then you count how many times you had to move the decimal point to get it there. So the decimal point started at the end of the number, and we had to move it 1, 2, 3, 4, 5, 6. Okay, so the rule is that the number has to be between 1 and 10, which this one is. Now, if you had a big number, then the power of 10 will be positive. Now here we did have a big number, so it's going to be positive 6. On the previous one, we had a small number, 0.00084. I don't know if I said the amount of noughts that were there, and you can see that the power in the question was negative. So negative power of 10 is really small number, positive power of 10, really big number. This does turn up on the calculator paper as well. So if it does, you can actually just type in question A into your calculator and just write down the number it gives you. Now some calculators are smart and do things in standard form, so you might need to do it this method anyway. Alright, so we're asked to draw a frequency polygon, and the only error you're going to make with this type of question is figuring out what a frequency polygon is. Now, a frequency polygon is where you put little crosses at the points, and the points lie at the group's midpoint. So we've got our first group 0 to 10, so the midpoint would be 5. Next one is 10 to 20, so that's going to be 15. Then 25, then 35, then 45. So the first one's going to be at 5, and it's going to be 6 high. It's going to be like that. Next one's 15, 22. So 22 would be about there. 25, 59. So 59 would be right up here. 25. 35, 15. A little bit lower than that, but that's fine. 45, 4. Now we're only halfway done, and my points aren't exact because the screen I'm using isn't the most precise, but it's good enough. We're only halfway done because what we need to do is join these up with straight lines, so no curves needed. And when you join them up with straight lines, do not ever join up the last 2 points. You're not actually trying to make a polygon, okay? So don't ever, when you join them up, whatever, right? Don't ever draw this line here, okay? That's not a good thing to do, so make sure you don't do that. Okay, and that's it. So midpoints, crosses, and then join them up with straight lines if you're asked for a frequency polygon. Alright, so it says that the town council is saying that over a quarter of the stores get over 30 customers. So we're going to see whether that's right. So over 30 customers would be these two groups here, so 30 to 40 and 40 to 50. So that is 19 altogether. So that's 19 out of, and let's add all the rest up, so 6 plus 22 plus 59 plus 15 plus 4, out of 106. It didn't say it in the question. So it's 19 out of 106, which as a decimal, 19 over 106 would be 0.179 to 3 decimal places. So what I would say in the exam is no, because that is 17% or 17.9%. So it's less than 25%. And just write a sentence saying that yes, it's close, but it's not quite at 25%, because even rounding up to the nearest percentage, it's 18%, which is 7% lower than 25%. So just make sure you write all of the numbers in an answer that answers the question. Okay, so we have a set of simultaneous equations, and I'm just going to start off by just writing them out to give myself a bit more room, because it's a little bit too small otherwise. So I'm just copying out the question. Now, there's a list of things we need to do for these, and there are different methods. I'm just going to go through the main one. The first thing is I need to get either the x's or the y's the same coefficient. So the number before them needs to be the same, ignoring signs. Now looking at this, and I'm going to label these A and B. Looking at this, if I double A, then the x's would become the same because they both have a coefficient of 4. So what I'm going to do now is I'm just going to write 2a. So I'm going to double everything in a. So double the 2x to make 4x to make the x's the same. Double the 5 before the y, so that's 10y now. And double the 24 to make 48. Now next I need to probably, and it's normally the case, if I write down b again it just makes things easier. So I'm just going to literally copy down b underneath. Okay, so next I'm going to remind myself that I'm working downwards now. So I just put little circles around these to remind me I'm going downwards. And I need to look at the sign before the letter that I've made the same coefficient. So I'm looking at the x's and I'm looking at the signs before them. If the signs are the same, we are going to subtract. If the signs are different, we're going to add, and it's that simple. Okay, now the signs are the same because they're both positive, so we are going to be subtracting. So minus there, a minus there, and a minus there. Okay, let's start. 4x take away 4x is nothing, which is good because it needs to be nothing. 10y minus 3y. Now 2 minuses make a plus, so that's 10y plus 3y, which would be 13y. And we've got 48 plus, because the 2 minuses make a plus 4, which is going to be 52. I'm going to put my lines in. Okay, next I need to do 52 divided by 13. And we're going to do both of these divided by 13. So we've got y equals, I think it's 4, so 4 times 13 is 52. So yeah, y equals 4. Then I'm going to pick one of the equations from the question and I'm going to substitute the 4 in. I'm just going to pick the top one. So 2x plus 5 times 4, because we know that y is 4, equals 24. And again, put my lines in. So it's 2x plus 20 equals 24. Take away 20 from both sides. 2x equals 4. Divide both sides by 2. Extend my lines a little bit, and x equals 2. Now if you've got time in the exam you can check that that's right by using the second equation. So 4 times 2 is 8, 3 times 4 is 12, and 8 take away 12 is minus 4, so we know it's correct. So x is 2 and y is 4. So this question looks quite complicated at first, but actually there are two very simple-ish ways of doing it. We've got 2 decagons, and so that means they are 10-sided. And you can just count the sides if you want, but you know, if it says it's a decagon, I trust it, it's a decagon. Now what we can do is we could work out the interior angles of the decagons. Well, they'll be the same, so I can just work out 1 and then double it, and then take that away from 360 to work out A. And that's absolutely fine, that'll get you the right answer. A quicker way maybe, and especially on the non-calculator paper, but it works on both papers, is to draw a line up here and realise that you've got 2 exterior angles there. And the beauty of exterior angles for polygons is they always add up to 360. So to work out the exterior angle, always write down what you're working out. All you need to do is 360 divided by the number of sides the regular polygon has, and they have to be regular, otherwise you can't just divide them because we're assuming they're the same. So that's 36. So if that one's 36 degrees there, and that one's 36 degrees there, then all you need to do is 36 times 2. Well, 6 times 2 is 12, 30 times 2 is 6, so that's going to be 72. So let's show the examiner that. 36 times 2 equals 72 degrees. Okay, so question A is about reverse percentages. So in 2014 and 2015, well, let's have a look. So the sales went down between the two. So if we start off with 100% and they went down 12%, what we're left with? Well, we're left with 88%. Now, as a multiplier, and this is the best way of doing this, 88% divided by 100, make it a decimal, is 0.88. Now that number, 0.88, is what we times the 2014 sales to get 2015. But in this question, we're given the 2015 sales, so we're given this one here. So we want to work backwards. So what we want to do is I'll get my calculator, 7,359 divided by 0.88, and that gives me £8,362.50. You've got to ask yourself, well, is that reasonable? Well, they went down by 12%, so it's natural that they would go from a number around just over 8,000 to a number that's just over 7,000. So I'm going to write the answer, £8,362.50. Okay, and the next question says that the sales went up in 2016, or they have a target to get their sales up in 2016. What's the percentage increase? Now, percentage increase or percentage decrease, it's the same formula, is change over original times 100. So the change, well, that's going to be 12272, take away the 2015 sales, so that's that one there, 7359. So they're looking for it to change by 4,913. The original was at 7,359, and we need to times by 100. So I'm going to divide that by 7,359, times it by 100. And that gives me 66.7617, blah, blah, blah. It says to the nearest percent, so that's going to be 67%. Okay, so this question, it looks like a standard bearings question, but something you might notice is there's no angles in it. So if there's no angles in it, we need something else, and that something else is going to involve the right angled triangle here. So we can see there's a right angled triangle here, and we know that when we've got right angled triangle, we've got two sides, we can find an angle with trigonometry. I'm going to call this angle x. Now to find x, we need trigonometry, and to do trigonometry, we need to label the sides. So we've got the opposite here, which is opposite the angle we want. We've got the adjacent here, and we've got the hypotenuse here. Well, the hypotenuse is no interest. We're not looking for it, and we're not given it. So it's O and A. So writing Socrates or Toa. Well, we're not interested in the H, so it's not going to be So, and it's not going to be Ka, so it's going to be Toa. So Toa stands for tan x equals opposite over adjacent, and the opposite is 47, and the adjacent is 72. Now we want to work out what x is, so to do that we want to inverse tan both sides. Okay, let's just scroll down. Okay, so on the calculator you want to click shift or the equivalent on your calculator and then tan, and then you press the fraction button, 47, and go down, 72. Just don't forget to close the brackets. Every time you click tan or inverse tan, it opens a set of brackets. Just make sure you shut them. Let's press equals, and that equals 33.1356 blah blah blah. Okay, let's have a look. So x is 33, but we still haven't got a bearing. What we can do is work out what this one is, and I'm going to call that y. So to work out what y is, it's going to be 33.1. Well, we're looking for nearest whole number, so let's call that 33. And then we're going to add the right angle here. Now, the reason I know this is a right angle here is because it says that he heads west and then south. So I know that both the angle here and the angle here are going to be right angles, because the angle between all four, north, east, south and west, all four directions are going to be right angles. So I'm going to add 90. And you can do this in the calculator, or you can do it in your head. I'm going to do it on the calculator. 123. Okay, now bearings, something that we've got to remember, are always from north going clockwise. So it's always going to be like that. It's going to be that angle there. So to do that, we're going to do 360. We're going to take away the 123 because that's what we don't want. So on the calculator, 360, take away 123, and that's 237. So the answer is 237 degrees. There are a few different ways of answering this question. I'm going to show you what I feel is the easiest technique, but if you've got a different technique you get the same answer, then stick with it. This question will all be about multipliers and understanding how to use them, but the difficulty in this question is we're finding out how long it will take to get to a certain point, which is a big twist in this question, and we're not given a quantity. Now, whenever you're not given a quantity, one method of being able to do it is by putting in your own quantity, and the easiest quantity to put in is the number 100. So I'm going to pretend that the population of the town at the start is 100. Now this question, as I said, is all about multipliers, so we need to figure out what a decrease of 6.5% as a multiplier is. And to do multiplier, you start off with 100%, you do whatever the question's saying, so this time we're decreasing by 6.5%, and this will be on the calculator paper, so you might as well use your calculator to do 100 take away 6.5, and hopefully the answer is 93.5%. And to convert it into a multiplier, you just divide by 100. You're just converting it to a decimal, but the paper will call it a multiplier. That would be 0.935. So whenever I times something by 0.935, I've decreased it by 6.5%. Okay, so we've got 100. And what I want to do is figure out how many times I need to multiply it by 0.935. Okay, so there's a power here which we don't know yet, to get the answer that is less than 47% of it. Well, the reason I pick 100 as my quantity I've made up is because 100 is nice and easy, because 47% of 100 is 47. So we need it to be less than 47. Now what I do on my calculator is I type in 100 and I times by 0.935 and I get the answer of 93.5. Now what I'm going to do now, and that's one time, what I'm going to do now is press answer times 0.935, and what that will do is allow me to go through this same calculation as many times as I want by just pressing the equals button. So I'm going to press the equals button once and I get the answer of 87.42. So I've done twice in total so far, and I can leave a little tally mark here. I press it again and I get 81.7. Again 76.4. Again 71.4. Again 66.8. Again 62.4. So I'm getting closer. Again, 58.4. Again, 54.6. Again, 51. I'm getting close. Again, 47.7. So I'm getting very, very close, but I'm not quite there yet. And I press it one more time, and I get 44.6. So in total, I've done it 12 times. Now, I'll always want to check that because my counting is not necessarily the best when under pressure. So what I'm going to do is I'm just going to do 100 times 0.935 to the power of 12 to check that I've got this right. So 100 times 0.935 to the power of 12, and I get 44.64. And I'm just going to check that that was the first time it went under. So I'm going to do to the power of 11, and what I can do is just scroll through my working out on the calculator and change the 12 to 11 and press equal, and that's 47.744, blah blah blah. Okay, and each of these are rounded. Okay, so it's going to take 12 years because 11 years gets us close but not quite over the line. It's the 12th year that it dips below 47%. Now, as I said, there are different methods. You don't need to include the 100 as a made-up value. What you can do is just look at the multiplier and wait until the multiplier is 0.47 or below, below 0.47. And the multiplier would go down to 0.4464, blah, 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 blah. That's absolutely fine method. And there are other ways of doing divisions, which I'm not going to go into because you don't need to go that far. Because when you hit A level, there's a much, much better way of doing it, but we don't go through it at GCSE. If you wanted to look into it, it's to do with logarithms, but we won't go into that. Now, there are two things you always want to try and get rid of when you're rearranging equations or formulas. The first thing is fractions. So this fraction here we want to get rid of, and we do that by timesing both sides by y minus 5. So I'm going to write out the equation again just to make it a bit bigger. And we can imagine that there's brackets around the top and bottom of this, and that sometimes helps us to answer the question. I'm going to put my lines down. So the first thing I want to do is times both sides by that y minus 5. And you must do that. You can't access the numerator of the fraction otherwise. So this ends up with being x brackets y minus 5. And on the right hand side, it's just the same numerator but without the denominator. Now, I said there were two things you've got to get rid of. The first one's fractions, the second one is brackets. You've got to break them open. So we're going to times out these brackets. So we're going to have xy minus 5x. And the right hand side hasn't changed at all, it's just 10 minus 3y because we haven't done anything to both sides. So what I want to do is try and get all of the y terms to the left hand side and all of the other terms, so the x terms, the number terms, whatever, on the right hand side. So I'm going to add 5x to both sides, but I'm also going to take away, add 3y to both sides as well. So I'm doing 2 in 1 here. So it's xy plus 3y. And on the right hand side we've got that 10 that hasn't moved plus 5x. Okay, when we have this situation where we've got the brackets gone away and everything is, all the y's on the left hand side, and y is what we're looking to do it in terms of, what we want to do is factorize it, so we've just got a single y. So y on the outside, x plus 3. Now I know I said I wanted to get rid of the brackets, but we need the brackets here to be able to get y on its own. And the last step here is we just divide both sides by the x plus 3. So we get y on its own. So we get y equals 10 plus 5x over x plus 3. So let's put that into our answer box. Now it can be either way around here. It could be 5x plus 10. That's absolutely fine. Still the right answer. Over x plus 3. To solve a quadratic, first thing you need to do is get it equal to 0. So I'm just going to write it out first of all. And then I'm going to draw my lines down so I can show the examiner what I'm doing. So the first thing I'm going to do is take away 6x both sides. So it's going to be x squared plus 7x minus 14 equals minus 10. And then I'm going to get rid of that minus 10, so I'm going to add 10 to both sides. So it's going to be x squared plus 7x minus 4 equals 0. Now the first thing I do is look at it and go, can I factorise it? Well, given the fact that it wants an answer correct to 2 decimal places, that's a bit of a hint that you're not going to be able to factorise it. Because when you factorise it, you'll normally end up with a much nicer number. And if the coefficient of x squared is 1, you'll end up with an integer. So we're going to have to use the quadratic formula, and there are other methods, but the most common one is the quadratic formula, so that's what I'm going to do. So the quadratic formula says x equals minus b plus minus the square root of b squared minus 4ac over 2a. Now you might say to yourself, well, what is a, b and c? Well, hopefully you don't, because if you're doing this question, I would assume you do know what a, b and c are. But for those of you who don't, a is the number before the x squared, b is the number before the x, and c is the leftover number. Now, the number before the x squared is 1, because there's no number there, so it's 1. The number before the x is 7, and the number on its own is minus 4, and that's really important that you understand that that's not 4, that's minus 4. So when I substitute it in, so b was 7, so it's minus 7 plus minus square root of b squared, well that's going to be 7 squared, so I know that's going to be 49, so I might as well write 49. Now it's minus 4 times a times c. Now a is just 1, so we can ignore that. Minus 4 times c, which is minus 4. Well, minus 4 times minus 4 is going to be a positive 16 over 2 times 1, which is just 2. Now you could, at this very early point, just type this into the calculator and that would be absolutely fine. Just make sure you put brackets around this and put any negatives in using the special minus button, which on the Casio calculators is 2 spaces above the 7. Okay, let's keep going there. So I might as well just type this in now. Well, I can finish it off. I can do the 49 plus 16 without a calculator. So let's keep going. Let's do it without a calculator for a little bit. So that's going to be square root of 65 over 2. Okay, this plus minus thing here just means that there's going to be a plus answer and a minus answer. So we split it up into 2 at this point. We have x equals minus 7 plus root 65 over 2, and we have x equals minus 7 minus root 65 over 2. And what you can do is just type that into your calculator, press the fraction button, then minus 7 plus root 65 over 2, and then you press equals, and that gives an answer for us. So I'm going to put that straight in, I think. No, I'm going to show the examiner, I know. I'm going to show the examiner. So 0.531128 blah blah blah. And then what you can do is on the Casio calculators you can just use the cursor button, which is the big blue round one, to move across, go to that plus, delete it and change it for a minus. It saves you having to write the whole thing out again. And then let's have a look. And if yours comes up as a fraction or something, just press the S to D button. It converts it. That's minus 7.5531128 blah blah blah. Okay, it says to round it to 2 decimal places, does it? Yeah. So we want 0.53. So 0.53. What else? Minus 7.53. So minus 7.53. There's our answers. The first thing to do with this question is, instead of drawing y is greater than 2, just draw y equals 2, and you do that by just finding out where y is 2. Well, y is 2 here, y is 2 here, y is 2 here. So it's going to be a horizontal line crossing the y-axis at 2. So that's the line y equals 2. Now, the inequality says y is greater than 2. So what I want to do is shade out the region that we're not looking at. So we're going to shade out this bottom region here because we don't want that. And some teachers say shade in the region you want, but it's a lot easier to see the region you want if you shade out everything else. Otherwise you're looking for overlapping regions. Okay, so that is done. So we can cross that off. Okay, next one, we want to do the line x equals minus 1. Okay, so where does x equal minus 1? Where does there, in fact all the way up this line here. So we want to do another one. And that's the line x equals minus 1. Okay, so where do we not want? Well, x is going to be greater than minus 1, so we don't want this bit at the side here. Now, on both of the ones we've done so far, y and x can't be on that line. So instead of a straight line, we should really do a dashed line to show that it actually can't be on that line. So I'm just going to make this a dashed line. Okay, now the last one, I'm going to do the line y equals x plus 2. Now, there's multiple ways of doing this. You could do a little table and find out where the coordinates are. So you could do 1, 2 and 3, and I'm just making those up. It could be 0, 1, 2 and 3. And 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 2 is 5. So that's our 3 coordinates to be able to draw the line. Or you could just say, well, the gradient of x is 1, because technically that's 1x, and the y-intercept is 2. So it's going to cross the y-axis at 2, and it's going to go up 1 for every one it goes across. And notice that matches my coordinates as well. So let's draw that in. So down there we go. So it should be that line there, shouldn't it? Okay, now the complicated part of this is figuring out which side of this line to shade in. So what I do is I always pick a point. So let's pick this point here. It doesn't matter which point you pick. So at that point there, x is 4 and y is 3. So what we want is y to be greater than or equal to x plus 2. Now x plus 2 is going to be 4 plus 2, which is 6. So is 3, which is our y coordinate, greater than or equal to 6? Well, no, 3 is not greater than or equal to 6. So that shows us that we want to shade in this bit because we don't want this bit. So that coordinate was part of the region we didn't want. Now you can do the same on the other side with a coordinate, say this one here. So x plus 2 is 2 plus 2, which is 4, and y is 7. So 7 is greater than or equal to 4. Okay, last thing to do is just label it with an R. So that's the region I'm looking for there. So I label it with an R. The easiest way I've found to work with bounds is just draw a number line, put the number that you've got, so we're looking at x, put the number you've got in the middle, try and figure out what the next number down would be. So the next number down would be 1.1 if they're rounded to the nearest 1 decimal place. What's the next number up? Well, it would be 1.3. So the next thing to ask yourself is, where's the cutoff point? What stopped it from being 1.1? Why did it round to 1.2? So the lowest it could be is halfway between those two numbers, which is 1.15. So that is our lowest bound, lower bound. The upper bound, the higher bound, would be here, which would be 1.25, but we're not asked for that. So 1.15 is the cutoff point. Now this is a slightly harder question in B because we're given this formula here. Now we've got to be careful when we're using formulas. We're looking for the upper bound of t. So we're looking for t to be as big as possible. Well, for t to be as big as possible, x needs to be as big as possible because we're adding it and we want a number to be big that we're adding. But the bigger y is, the smaller that fraction becomes. So we want actually y to be as small as possible. If you ever think about it, the fraction a half and the fraction a third, which is bigger? Well, a half is bigger. So the smaller the number at the bottom, the bigger the fraction. Anyway, a little bit of a side note, but that's really important that you remember that if there's a denominator, that we want it as big as possible to make the smallest possible number, or as small as possible in this situation to make the number as big as possible. So we need to find the upper bound for x and the lower bound for y. So using the diagram I drew earlier, 1.25 is the upper bound. Now you might say to yourself, well hang on, no, technically 1.25 would round to 1.3. Okay, let's delve into that a little bit. The actual answer should be 1.249 recurring, but there's two reasons I've not written that. The first reason is that it's a pain to work with. Typing that into the calculator would be a pain. The second thing is that actually 1.249 recurring is the same as 1.25. They are exactly the same number. Now if you don't believe me, a little bit of a side note, a third is 0.3 recurring, 2/3 is 0.6 recurring. Following the same pattern, 3/3 would be 0.9 recurring. But we know 3/3 is the same as 1. So 0.9 recurring is the same as 1. There is no difference, and that's very difficult to get your head around. Anyway, side note over. So the upper bound of x is 1.25. So we need to do a little number line to get the lower bound of y. So it's 4.6. So the next one down would be 4.5. So the cutoff point is going to be halfway, which is going to be 4.55. So that's going to be our lower bound, 4.55. So to find the upper bound of t, we need to do 1.25 plus 1 over 4.55. So let's just do that on the calculator. 1.25 plus fraction button 1 over 4.55. And I get the answer 1.46978 blah blah blah. It says it wants it to 2 decimal places, so it's going to be 1.47 because that 9 would round that 6 up. This question could be a show that question where it gives you the decimal and the fraction, or it could just ask you to work it out. So it could turn up on either paper. So the first thing I'm going to do is just convert this. I'm just going to be investigating this first, and then I'll worry about the 0.0 later on. Okay, so way of doing this is get x equal to 0.8686 blah 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 recurring. Now we need to bring that 86 in front of the decimal point, so I'm going to times it by 100. So I'm going to work out 100x is 86.8686 blah blah blah. And then what you do is you just take away going downwards. The reason we do that you will see in a second. So 99x, because it's 100x take away x, which is 99x, and it's 86 point recurring pattern take away 0 point recurring pattern. The recurring patterns take away, so we're just left with 86. I'm then going to divide both sides by 99. So it's x equals 86 over 99. Now, I said I'd ignore the 0.0 bit. I'd ignore this bit earlier. Well, I can't ignore it anymore. So how do I get from 0.86 recurring to 0.086 recurring? Well, I'm just going to divide by 10. So what I want to do is I want to do 86 over 99 divided by 10. Now the way I can do that is just times the bottom of the fraction by 10, and that's the same as dividing it by 10. And we should write 0.086 recurring equals to show the examiner that that's what we're doing. Okay, so we can cancel at this point. If you have a look, we can divide top and bottom by 2. So we're left with, I can show that I'm dividing by 2. So we're keeping the fraction the same. So that would be 43 over, and half of 900 is 450, half of 90 is 45, so it'd be 450 plus 45. And you don't need to show this working out, but I'm doing it just to show you. So it'd be 495. Now, I don't think there's another number that goes into 43 and 495, so I'm going to sort of leave it there. Normally when you're asked to simplify, or normally when the numbers are big, you won't be asked to simplify it, or there will be a very easy way of simplifying it. This seems like quite a complicated question, but if you break it down into steps, it's much simpler. We need to find out first of all what the area scale factor is. Now, it's important that you realise that there is a linear scale factor, an area scale factor, and a volume scale factor. To work out the area scale factor, I'm going to get the 1731, which is the new size, and divide it by the old size, which is 2328. So I'm going to get my calculator, and 1731 divided by 2328. And when I do that, I get a horrible decimal. Now you can write it as the fraction that turns up, which is 577 over 776. We can write it as decimal, but keep it in your calculator, because the next step is to work out what the linear scale factor is. Now, there's no linear involved in this, but we need the linear one to then find out what the volume scale factor is. Now, to find a linear scale factor from an area scale factor, all you need to do is square root it. So I'm going to square root 577 over 776, or I've just kept it in my calculator. So what I'm going to do is press the square root button and then just answer, which is at the bottom of the calculator, bottom of the Casio calculators. Press equals, and it now gives me a decimal of 0.8622, blah blah blah. And when I do the little dashes at the bottom there, I'm showing the examiner that I'm going to keep it in my calculator. I'm not going to round it. Right, so we need to work out the volume scale factor. Now, to find the volume scale factor from the linear scale factor, you just cube it. So I'm going to show the examiner that I'm going to keep it in my calculator, but I'm going to cube it. So what I'm going to do is just press the X with a little square button, and then 3, or just press the X cubed button. Let's have a look, and that's going to be 0.6411, and again I'm going to keep it in my calculator, because the last step is to find out what the new grams is. Now, the reason we need the volume scale factor is grams is a three-dimensional thing, okay? So it's going to be involved in the volume. Yes, with volume normally it's centimeters cubed, but grams works the same way as centimeters cubed. So to work out the new weight, I'm just going to get 319, and I'm going to times it by that 0.641 blah 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 blah. So on my calculator I'm just going to times it by 319, and I get the answer of 204.5322 blah blah blah. It says it wants its two decimal places, so 204.53 is going to be my answer. Looking at the structure of the answer, it looks very much like we're going to have to complete the square. Now, to complete the square, we need x squared minus something, okay? Now, we've got 2x squared,
and so minus something x. We've got 2x squared minus 28x. So we're close to getting that, but we haven't quite got that. So what we need to do is factorize the 2 out first. So 2 brackets x squared minus 14x. And then I'm just going to add the minus 4 at the end. You could also factorize out the 4 as well, but I'm just going to leave that alone because I'll deal with that later. Now that we've got what we need to be able to complete the square, which is the x squared minus something x, we are going to complete the square. Now to complete the square, and I'm going to do this over here to show you a little bit easier. What you need to do is you need to put the x minus half of the bit here, so it's going to be 7 squared. Now that will get, if you expand that, that will be, or using FOIL, that would be x squared minus 7x plus 49. Now we need the x squared, we need the minus 7x to get the minus 14x, but we want to get rid of the plus 49 that it generates. So we need to take away 49 from it. And that's it. That's completing the square. Okay. So I'm going to replace that with what I've just found out that it is x minus 7 squared minus 49. Now, I have that minus 49 on the inside of the brackets, and I want to collect that with the minus 4 on the outside of the brackets. So I'm going to just expand the big brackets. So I'm going to times the x minus 7 squared by 2. And I'm going to times the minus 49 by 2. And so I can collect the numbers together. So looking at the question, it says it wants m. M is the thing before the brackets, so m is going to be 2. Now it says that p is a positive. Well, we know that p is minus 7, so I'm going to put minus 7 there. And q, it says, is a positive. Well, we know it's a negative, so it's going to be negative 102. This is a question about iteration, and question A is a little bit harder maybe than the exam will go, where it asks you to come up with your own iteration formula. So, in order to do this, it says that fx equals 0 for this formula. So the first step is just to get it equal to 0. Now the question's given you a hint because it says that it involves a cube root. So we know that we're going to have x cubed equals something, and then we're going to cube root both sides. So I'm going to just put my lines down. And we're going to add x and add 5 both sides. And we're just going to cube root both sides. So our iteration formula is going to be the cube root of x plus 5. Now, with the iteration formula, it's a beautifully simple idea that this formula will, as long as we just keep ploughing in what we've found for the answer before, it will get us closer and closer to the real root. Now, sometimes the roots are infinite, so we could be sitting there all day and it will get a closer and closer and closer answer. This is why the question will say, oh, 3 decimal places or 4 decimal places. So that will tell us when to stop. So it always will give you a first one, okay, the x0, the first one to try. And all you're going to be doing is putting that 1 into this formula here. Okay, so let's try it. So cube root of 1 plus 5, and that gets me 1.81712 blah blah blah. Okay, now I need to keep that answer, so what I'm going to do is I'm going to press the cube root button, then I'm going to click inside the root, I'm going to click answer plus 5, and and the calculator will remember the answer to the one we had before. Now, if you try and round them, you will get very, very different answers, and it might take you a little bit longer, or you might make a mistake. So you let the calculator do all the remembering for you. Then I press equals, and I get 1.89612, blah, blah, blah. So I'm going to do the same again. So I'm going to do the cube root button, answer plus 5. And we've got 1.9034, blah, blah, blah. Cube root button, answer plus 5. And we've got 1.9040, blah, blah, blah. Now, we're looking for 3 decimal places, so the numbers we're looking for being the same is these ones here. Now, we've almost got them the same, but we're not quite there, so we need to do another one. So cube root, answer plus 5, and we've got 1.9041, blah, blah, blah. Now, even if you were to carry on going, the first digits, the digits I've circled with I've put a red square around, are going to remain the same. So as soon as you get 2 that are the same to 3 decimal places, that is your answer. So my answer is going to be 1.904. Now, obviously we haven't got it perfect, but if you carry on the iteration, you won't ever get anything different to 1.904. The only numbers that will change are beyond that. So that's why we can confidently stop now and say, yes, that's our answer.
Okay, I hope you enjoyed that video. Like I said, you can do the questions online. On the online paper, all the numbers constantly change, so you're not just remembering answers, you're remembering techniques. We also have the new Revisionator online, which is a really, really good tool to just do random questions. We also have mock exams, demon questions for the harder questions on the GCSE course, mini mocks, and there's all sorts of other things on the website. We also have the remaining topics on our website, which you can just go through all the exam questions we have for the remaining topics. If you like this video, please click like, and if you want to see more from us, click subscribe. Thank you very much.